So let us start the last topic, digital to analog converter. Now, basically, what is digital to analog converter? You will give digital input. Suppose this is a 4-bit D2A converter. 4-bit digital to
सर
analog means D2A. Yes.
सर एक बार प्लीज माइक से कर लीजिए, आवाज इतना अच्छा नहीं है।
अच्छा. Now it's okay. अभी ठीक है?
सर ठीक है, पर थोड़ा सा
Okay. Okay.
नॉइज है।
Noise आ रहा है. Slicer ही है. Okay. Laptop का noise आ रहा होगा. Okay. Now suppose you have a D2A converter. Okay, we are D2A converter. Now you have a 4-bit D2A converter. 4-bit D2A converter means you have a 4-digit binary digit. Okay, by 4-digit in digital form. Like you have a D3, D2, D1, D0 type of bits. So this is your MSB and this is your LSB. Okay, so now what D2A converter will do? D2A converter will convert this digital input into the analog output. Okay, and this analog output will be proportional to your digital input. If I want analog output, that will be K into digital input. Now here you understand that this conversion is not a true conversion. Okay, true conversion मतलब ये absolute conversion नहीं है. This conversion depends, okay, that which D2A converter you're using. That is a 4-bit, 3-bit, 2-bit, and what is the maximum voltage range. So basically it's a conversion. Okay, now this 4-bit, 4-bit, if you take combination, total we have a 0 to 15 numbers. Okay, and then we have to see what is the maximum range of V output. Okay, suppose maximum range of V output is 15 volts, and here we have a total 16 combinations. Okay, 16 steps. Okay, so 0 will be 0, 1 will be 1 volt, 2 will be 2 volt, and similarly 15 will be 15 volt. So this type of conversion will do. So that depends on how much bit is there, how many steps are there, and what is the maximum range here. Okay, so what I'm trying to say, the resolution of a D2A counter, resolution of a D2A counter, also this is called step size. Step size, this is defined as a maximum voltage range. Called this is full scale voltage. Full scale voltage divided by number of steps. Number of steps. Okay. What do you mean? So if your full scale voltage is V and number of states is given by 2 power n minus 1. Okay, like you have a 3-bit 3-bit D2 converter, then it will have a 2 power 3 minus 1, 7 steps. 2 power 4, you will be doing 15 steps. Okay, now for example, if I want to calculate the resolution of a 4-bit counter, so if I want to calculate the resolution of a 4-bit counter and full scale voltage is given 16, say full scale voltage, okay, this is 15 volts. Okay, and we have a 4-bit D2A counter. Okay, so it will be having steps, total steps equals to 2 power 4 minus 1, that is 15 steps. Okay, 15. So now if I calculate the resolution, so it will be 15 upon 15, that will be your 1. Okay, so resolution will be your 1, and in terms of volt, it will be 1 volt. Okay, so
सर
resolution
सर कभी कभी आवाज सही नहीं आ रही है सर.
is it okay now?
यस सर अब ठीक है.
So basically you have a full scale voltage, okay, 15 volts, okay, and a number of steps is your 15. So your resolution will become 1 volt. Okay, so what does mean? If you have 4-bit counter, okay, so you will be having 000 term, okay, digital input, 0000, okay. Here you have analog output. Okay. So analog output will be corresponding to 00, it will be 0. Okay. Now suppose you have a 001. So this is LSB. Okay. So step size or resolution is also equal to the weight of LSB. Weight of LSB. Okay. So now the weight of LSB is 1 volt. So the if you will get the output equals to 1 volt. Okay. Similarly, if you have a 0010, you will get output 2 volts. If you have a 0011, you will get output equals to 3 volt. Okay. So on you will go for 111, you will get the full scale voltage equals to 15 volts. Okay. So for example, if you have a 0 steps, you 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So suppose you have a 15 full scale voltage. So this will be 1 volt, 2 volt, 3, 4, 5, 6, 7, 8, 9. Okay. And if you keep on going 10, 11, 12, 13, 14, 15. This will be your 10, 11, 12, 13, 14, 15. Okay. So there will be total 0 to 15 volt. There are 15 steps. Okay. And this is the width of one step is called a step size. So if your full scale is voltage 15, and if you are using 4-bit D2A counter, so your resolution will be 1 volt. Similarly, if I use now a 5-bit counter, then what will happen? My resolution will decrease. Okay, because 5-bit counter will have a more number of bits. Okay, so as the number of bit increases, the resolution of your D2A counter will increase. So for example, here you have total 15 steps, and one step is equals to resolution. Okay. So for example, a question came in gate that is a full scale voltage of 3 bit D2A counter is 7 volt. So writing questions. Full scale voltage of 3-bit, full scale voltage of 3-bit D2A converter is 7 volt. Okay, they are asking what is the weight of these inputs 0 0 0 0 1 0 0 0 2 0 sorry 0 0 1 0 and 0 1 1. What is the weight of these 3 digital inputs? Okay, now we have been given 3-bit D2A converter, full scale voltage is 7 volt, so we know the resolution will be what? Resolution or step size will be 7 upon 2 power n minus 1, that is 2 power 8 minus 1, 2 power 3 minus 1, that is 7, 7 upon 7, again this become 1 volt. Okay, so your the weight of LSB will be 1 volt. Okay, the number, this is 2, so this will be twice, because the analog output will be always proportional to digital input. So this is 1 volt, so this will be twice of this 1 volts, 2 volt. This will be a 3 volts, and this will be 0 volts. Okay, so this is digital inputs. and this is your analog output. Okay, so once you have calculated the resolution, okay, you can do conversion very easily. Now comes, so what is percentage resolution? Okay, so this is the formula you have to remember, resolution. Okay, now what is percentage resolution of D to A converter? Percentage resolution, okay, that is given by step size upon full scale voltage into 100. Okay. Now you know step size, full scale voltage, like here is 15 volts, okay, that is equals to step size into number of steps. Okay. So suppose I want, this is full scale voltage, so from here to here if I want to reach, step size is 1 volt, so I need 15 steps. So I can write full scale voltage equal to step size into number of steps into 100. Step size cancel. So if you want percentage resolution, that will be equals to 1 upon 2 power n minus 1 into 100. So this is the formula for percentage resolution. Now let us solve some problems based on this formula.
सर अगर जैसे रेजोल्यूशन 2 वोल्ट आएगी रेजोल्यूशन, तो जब जैसे फिर हम ऐसे 0001 को 2 वोल्ट
जो भी रेजोल्यूशन आएगा, स्टेप साइज आएगा, वो आपका वेट ऑफ एलएसबी है,
वो 2 वोल्ट होगा 0001
आपका। जैसे 4 बिट है तो 001, 3 बिट है तो 001, 2 बिट है तो 01, ओके। तो एलएसबी का वेट होगा, जो भी आपका स्टेप साइज आएगा दैट विल बी एलएसबी का वेट होगा। बाकी आप उसको आउटपुट को मल्टीप्लाई करते जाओगे।
सर कैसे 2 वोल्ट आएगा तो एलएसबी का वेट कैसे सर? वो
जैसे आपका पहले बताओ कितना बिट काउंटर है आपका, आप जैसे बोलो स्टेप साइज है तो
जैसे यही वाला हम ले लें तो वो 14 वोल्ट फुल स्केल वोल्टेज ले ले और 3 बिट काउंटर ले लें तो 2 आ जाएगी ना
तो ठीक है, आप ले लो 14 वोल्ट ले लो।
यस सर।
ओके, तो स्टेप साइज कितना हो जाएगा? 14 अपॉन
7
2 वोल्ट आ जाएगा स्टेप साइज।
यस
ओके, सो दिस विल बिकम 2 वोल्ट्स। दिस इज द वेट ऑफ एलएसबी, दिस इज एलएसबी ना, 001 for LSB, so this become 2 volts, so automatically this become 4 volt, this becomes your 6 volt. Okay, proportionality increase होता जाएगा। Okay, K is basically what? Proportionality constant। तो मैंने लिखा था फॉर्मूला आपका एनालॉग आउटपुट is basically K into digital input। Okay, so K क्या है आपका कांस्टेंट जो है, which is equal to resolution or step size। So if you know this one, for any input you can find what is the analog output।
Okay sir।
Okay, so now suppose you have been given, this is determine the resolution of a number one 6-bit D2A counter। Okay, determine the resolution of a 6-bit D2A counter। Okay, percentage resolution, so determine the percentage resolution of a 6-bit D2A counter। So कितना हो जाएगा percentage resolution we know the formula, that is equals to 1 upon 2n minus 1 into 100. ओके, और 6 बिट है तो क्या हो जाएगा आपका 2 पावर 6 माइनस 1 टू 100. ओके, तो कितना आ जाएगा 1 upon 2 32 64 minus 1 into 100. This will be what 1 upon 63 into 100. How much is coming? What is the resolution? कितना आ रहा है
1.58.
1.58 percentage. That is the resolution. Okay, similarly if I take now 12 bit D2A counter, तब कितना आएगा तो 12 बिट कितना आएगा रिजोल्यूशन निकालो
0.0244.
0.0244. Okay, this is answer. So using the formula you can calculate. Okay, so that will be 12 is 2 power 12. Okay, minus 1. So calculating resolution is very simple. Now say I have a 6-bit D2A counter and step size is given to me 50 millivolt. I have a 6-bit D2A counter and step size is 50 millivolt. So what is the full scale voltage? What is the full scale voltage? Okay, and percentage resolution. बताओ So full scale voltage कैसे निकालते हैं full scale voltage that is equals to number of steps into step size or resolution. Okay, number of steps for 6-bit will be how much 2n minus 1 into step size is 50 millivolt. Okay, then how can you calculate 2 power 6 63 into 50 millivolts? Full scale voltage is how much? How much is coming?
3.15.
12.75.
3.15. 3.15.
ऐसा आएगा अभी 0 15 30 31. This is 31. So this is millivolt. So if you convert in volts, 3.15 volt. Let me check the answer. Yes, 3.15 volt is the answer. Okay, there's full scale voltage and percentage resolution. Just now we have already calculated for 6-bit, or you can calculate other way also. The percentage resolution, the formula is step size upon full scale voltage into 100. Okay, the step size you know already 50 millivolt, and you know this is 3.15 volt. Okay, 3.15 volts into 100. So this will be like same like this will be same like 1 upon 2 power 6 minus 1 into 100. Okay. So you already calculated to 6-bit. It was 1.5%. Okay, 1.587%. 1.587%. You can check, both are same thing. Now one problem came in GATE 2019. So they are asking, you have a full scale voltage given. Full scale voltage is given 10 volt. Okay. So they're saying, what is the binary input? What is the binary input corresponding to 6 volt? Okay. So what is the binary corresponding to 6 volt? Okay. And this is 3-bit T2A counter. There you are, a 3-bit T2A counter. What is the binary input corresponding to 6 volt? Calculate. So if you calculate the resolution or step size, so step size is basically full scale voltage, okay, upon number of step, that is 2n minus 1, 10 upon 2 power 3 minus 1, that is 10 upon 7, okay, that is equals to what? 1, 1.4 to 1.42, okay, and will be keep on going. So if you divide fully, how much will come? 1.42, then
8.
1.428 is correct.
Well, yes.
Okay, so this is step size. Okay, so now you want the binary input corresponding to 6 volt. Okay, so this is a 3-bit counter, so you know 0 0 equals to 0 volt. This is analog, and this is your digital input. Okay, 0 0 1, the weight of LSB is equal to this one, 1.428. Okay, so 0 0 1 0 will be equal to what? Twice of this one. Okay, so twice of this one will be what? 16, 1 to 4 5 8, okay, 2. If I want the weight of this one, this will be 3 times of this one, so 80, 24 2, okay, 6 to 8, 12 12 1 3 4, 4.284. okay, so this is a volts. Now if I want the weight of 100, okay, that will be equal to 4 times of this weight, that will be 4 3 11 1 7 1 5, it's going 5.7. okay, now what is the weight of 101? Tell me, what is the weight of 101? Are you getting how I'm doing this one? You know the weight of LSB, then you keep on multiplying 2 3 4 5. Okay, so what is the value now? Tell me.
7.14.
7.14. okay, so he asking what is the binary input corresponding to 6 volt. Okay, so this is close to 6 volt. Okay, so your answer is 100. Is clear this one? This question is clear? So let us do some more problem, and then we'll do different kind of D2 converters. Okay, so now suppose it says what is the largest value of output voltage? What is the largest value of output voltage? What is the largest value of output voltage? Okay, that is they are asking basically full scale voltage. Full scale voltage. Okay, for a 8-bit D2A counter, for a 8-bit D2A counter, okay, that produces 1 volt. Okay, that produces 1 volt. So 8-bit counter means 8 digit 0 0 1 0. So 1 2 3 4 5 6 7 8. So 8-bit D2 counter produces 1 volt for this one, for this digital input. So what is the full scale voltage? What is the full scale voltage? Full scale voltage means what? Full scale voltage means you have a, this is corresponding to this one. So what is the value corresponding 8 ones? Full scale means 8 1. So 1 1 1 1 1 1 8 1. So what is the value corresponding to this full this binary input? Okay. So how will you do? So you have been given the weight of this binary digital input equal to 1 volt. So you can calculate the weight of LSB now. Okay, because I told you the analog output is basically K into digital input. Okay, now the weight of this one. Okay, so if you see the digital equivalent of this one, so 0 0 1 1 0 0 1 0. Okay, if you take equivalent, so this is equal to basically 0 to power 0. Okay, 1 to 2 power 1. Okay, so this is basically your 0 1 2 3 4 5, 2 power 5 1 plus 2 power 4 1 and then 2 power 1 1. This is equivalent to this one. So this is equal to basically 32 plus 8 16. Okay, and plus this is equals to 2. So this become equals total because become equals to 50. Okay, so 50 equals to 1 volt. Okay, 50 equals to 1 volt. So 1 equals to 50 equals to 1 volt. So 1 equals to 1 by 50 volts. Okay, that is the step size K value. So K value is now what? 1 upon 50 volts. Okay, now you have 1 equals to K equals to 150 volts. Now you have been given this one, you want to find this one, and so this is equal to your basically 255. If you make a convert in digital, this is equal to 2 decimal, this is equal to 255. Okay, so you know the 1 is equal to 1 by 50 volts. So the full scale voltage will be basically 255 upon 150, and if you solve this one, this should come, how much is coming, tell me? What is the solution? What is the value of this one? How much is coming?
5.1.
5.1. No? So this is basically 10, and this is 25. Okay, so 5 1. Okay, so 5.1 volt. So that's the answer. Now we're going to do most important D2A converter. हाँ
सर 50 कैसे सर ये 1/50
हाँ बोलो ना वी कितना है ये क्या है डिजिटल इनपुट है
50 यस
इसके ये टोटल वैल्यू कितनी इसकी 550 है
यस सर
ओके तो 50 के लिए आपको कितना मिल रहा है 1 वोल्ट मिल रहा है
ओके सर
50 के लिए आपको 1 वोल्ट मिल रहा है तो 0 0 0.00001 के लिए कितना मिलेगा 1/50।
ओके सर।
सब प्रोपोर्शनल है, सारे प्रोपोर्शनल है ना। तो इसका वेट पता है तो इसका वेट पता चल जाएगा, इसका वेट पता है तो फुल स्केल वोल्टेज पता चल जाएगा। आर यू गेटिंग?
यस सर।
Now the R to 2R ladder type D2A converter. So what is R into 2R ladder type? Basically these are resistances connected to a op-amp. Okay, so we have combination of 2R and R. So this is your 2R, R, then you have 2R, then you have R, then you have a 2R. So D0, D1, D2, and then you have a R, then you have a 2R, and this is going to your operational amplifier. This is minus, this is plus, this is your grounded, and this is going here at the output. Okay, so call it this output is equals to VA. So now you can see this is a non-inverting type of amplifier. Okay, so basically not inverting amplifier. Okay, and this is your zero. So whatever, this is basically voltage follower circuit. Okay, voltage follower. So whatever voltage will come here the voltage will be same. Now this circuit, okay, will convert your digital input into analog output. So this is called R to R ladder type D2 converter. Okay, now here we have basically 4 terminals. So say this is my D3, D2, D1, D0. Okay, so basically this is your 4-bit R to R ladder type D2A converter. So whatever value you will give here, okay, in terms of digital input means what? If you give 0.001, okay, so basically your D0 is 1, D1 is 1, this is MSB, okay, this is your MSB and this is your LSB. Basically this is your D0, this is D1, D2 and D3. So whatever value you will give here, okay, correspondingly analog output it will convert into analog output. Now here 0.000 means 0 means low voltage, okay, and 1 means high voltage. So what is the value of here? Okay, suppose you are giving you want 0.0100 okay, so you'll put here 0.101. Okay, now you should know what is the value of 1 in the question. Okay, so value of 1 can be high voltage, can be 5 volts, 10 volts, 16 volt. Similarly low voltage depends, okay, it can be 0 or minus, whatever in the question is given. So what is in simplest form I'm trying to say, okay, this is your 4-bit R to R ladder. Okay, it can be 3-bit, n bit, okay, it can be n bit. So what is the conversion formula from digital to analog output? So I'm directly writing the formula for n bit counter, okay, and then we will derive that formula. Okay, so if you have a n bit D2A converter, okay, so for n bit R to R ladder type D2A converter, if it is given in the question में देगा कि ये इस type का converter है, okay, then the analog output VA corresponding to any bit can be written as V0 into 2 power 0, V1 2 power 1 plus V2 2 power 2 and so on, V power n minus 1 into 2 power n minus 1 upon 2 power n. Okay, so this is the formula. Now what is here? V0 means here what is the input is here at D0, whether it is 0 or 1. Okay, voltage की value यहाँ पर क्या voltage की value है, high है कि low है. Similarly V1 is your D1, D2 is your V2. Similarly D3 is your Vn minus 1. Because this is a 4-bit. Okay, so 4-bit goes from 0 to 3. Okay, 4-bit goes from 0 to 3. So this is n bit will go 0 to n minus 1. So what is the magnitude voltage here? Okay, and this will be always 2R R type. Okay, you can see if you have 4 bits, there will be four R to R combinations. So 1, 2, 3. Okay, like this. So if you put the values here, if you know what is the value of V0, V1, V2, you can put here. Okay, for example, if you want to calculate the weight of 1101, okay, so you can put here, you can make it 4-bit counter. So this value will go from V0 to V3. Okay, and you should know what is the V0. V0 is 1, V1 is 0, V2 is 1, V3 is again your 1. Okay, now you should know what is the value of 1. Suppose 1 value is 5 volts. Okay, and 0 value is 0 volts. So wherever 1 is coming, suppose here is 1 coming, you can write here 5 volts, 2 power 0. V1 0 coming, you can multiply 0 into 1. Okay, V2 is 1 coming, 1 means high voltage, you can put 5 volts. So in this way, for any given input, you can convert or calculate up on the equivalent value of your analog output. Okay, so let me solve a problem. So note down this formula first, and we will derive this formula later. Okay, so we'll understand how to use this formula, and then we'll derive this formula. So say we have been given a 1, 2, 3, 4, 5-bit D2A counter R2R type. Okay, so he says calculate the analog output equivalent to digital input 1, 1, 0, 1, 0. Okay, and you have been given 0 is equal to 0 volt and 1 is equals to 10 volt. Okay, so put the value in the formula and tell me what is the analog output. So this is a 5-bit. Okay, so V analog output will be correspond to this digit. Will be what? You have formula is what? V0, okay, into 2 power 0 plus V1 into 2 power 1 plus V2 2 power 2 plus V3 2 power 3, and we have to go 5-bit, we have to go up to 4. V4 into 2 power 4 power 2 power n. Okay, now this is 5 digit, so you can put here 5 here. So now you have 1.32. V0 is your 0, so 0. V1 is 1, 1 means your 10 volt. Okay, again V1 and 0, 1, 2 is your 0, so nothing 3. V3 is your 10 volt into 2 power 3, and V4 is again 1, so 10 into 2 power 4. Solve and tell me what is the answer.
Sir, 0 into 2
Sir,
power
20 comes are there.
Sir,
0 plus 20.
हाँ जी
0 plus 20 कहाँ से आ गया?
2 power 1. 2 power 1.
2 power 1. हाँ, B1. Okay.
20.
Okay. Correct. So 10 into 2 power 1. Okay, correct. then 203 then 4, correct. कितना आ रहा है?
8.12.
8.125. Okay, so the analog output corresponding to this digital input is your 8.125. हाँ, अब कोई क्वेश्चन है किसी को? Any question? For example, now you calculate 110. Now calculate the full scale voltage. What is the full scale voltage? Full scale voltage का मतलब क्या हो गया? What do you mean by full scale voltage? What do you mean by full scale voltage?
All are one.
All are one. Full scale means 1 1 1 1 1. So corresponding to what this digital input? What is the output? Tell me. What is the full scale voltage?
So 9.68.
It's a 9.68.
9.68 volt is the correct answer. Now let me derive this formula now. So basically, I'm applying voltages here. Okay, I'm applying voltage V3 here, V2 here, V1 here, V0 here. Okay. Now, because of all these voltages, I want to calculate what is the V input here. Okay. So basically, we have to apply superposition principle. Okay. So say, for example, for simplification, I'm saying I'm applying E voltages here. E maximum voltage E here, that is the value of 5 10. So say that is the value of E here. So if I want to calculate the output due to this digit, okay, I'll calculate the for each digit what is the, if this is 1, what is the output here, other 0. If this is a 1, others are 0, what is the output here? So basically I'm calculating the weight of each digit. Okay, so I'll calculate this one, I'll ground this one, I'll ground this one. So your D2 is ground, D1 is ground, D0 is ground. Okay, so alone because of MSB. Okay, MSB means now I'm calculating the 100 weight of 1000. Okay, so case first, I'm calculating the voltage corresponding to this digit 1000. So here the voltage is E plus E. Okay, now this is your voltage follower. So whatever voltage is here, this voltage, that will be equal to this voltage. Okay, so I'm calculating now VA. Okay, due to D3. Okay, now these two resistors are in parallel, isn't it? These two resistors are parallel. So 2R will give me how much? So this resistance are 2R, and this is your 2R. So 2R will give you R. Okay, so 2R will give you R. This is a combination will give you R. Okay, then you have R. Again you have R here, and again you have 2R here. Okay, suppose this voltage I'm applying here, so current will go like this. Okay, here, then it will go here, then it will come here, then current go here, and current will come here. So now the combination, this is R. Okay, so these now current will come like this here. So these two are in series. Okay, these two are in series, and again, so this become R plus R, total 2R, and again these two resistances. Okay, again they are in parallel. Are you getting? The combination, this will give you R, then R 2R again, and 2R R again. So this will be R. So again this will be R. Okay, and then further again this R and R become 2R, and 2R 2R R. So you will finally R. Okay, and then you have a R. Finally you have R R. Then you have a 2R, and then you have a voltage plus E here. Okay, and I am trying to calculate the voltage VA, the voltage across here. So this is point. This point is, if this point is clear, tell me yes.
सर एक बार ये रिपीट कर दो ये वाला.
So ये 2R कितना हो गया? R. Okay. Shall I make again this circuit fully with this 2R because मुझे बार-बार बनाना पड़ेगा ना इसको. अभी एक डिजिट कर रहा हूँ. So this 2R is R, isn't it? Both are parallel. So parallel में क्या होता है? 2R into 2R upon 4R. So R cancel, 1 4 cancel. So you have R. So parallel combination is R. Okay. Then this R is here. R connected to R. So R 2R. Then again they are parallel. Again will come R. Then R again will come R. Okay. So I'm stopping up to here. Okay. So I have R. This is R, and this 2R. And here is a battery. So this is not parallel. Now you cannot make parallel. Of course these are in series, but this is not parallel. Okay. This will be, because this is not ground now. This is a plus E. Now I want to calculate what is the voltage here. Okay. So what will voltage come? VA due to D3. Okay. Now current will go here because the amplifier is, there will be no current in this section. Okay. Because your operational amplifier. So all the current will go here. So the current will be what? I will be what? I will be your E upon 2R R 4R, isn't it? And this voltage E upon 4R into I want voltage here VA, that will be equals to 2R. So RR cancel, this cancel 2. So this comes out E by 2. Okay. So the weight of this digital input, okay, you have a weight of 100, okay, that comes out equals to E by 2. अभी क्लियर नहीं है तो बताओ. So when input is 100, that time your output, okay, plus 4 output is your E by 2. I am applying superposition principle. Be all the places you have some input, it may be high or low. So I am assuming here is high and this is grounded. So I am calculating the contribution due to this bit. So this comes out E by 2. Okay, is clear? Mardul?
Yes sir.
Okay. So abhi E by 2 aa gaya because of this digit. Okay. Now let me calculate when input is, now say when input is 0010. Okay. That means now this is grounded. Okay. D3 is grounded and you have high voltage at D2. This value can be changed. Like I'm putting EE. You can put something V3, V2, Vn minus 1 like this. Okay. So for a simplification, I'm putting same value here. So now here and these are all are grounded. Okay. Again, now I have to calculate. So input is 0, 0. Sorry, 0, 1, 0, 0. So input, this is my input. Corresponding this input, I want to calculate what is my V
0, 0, 1, 0 you said, sir.
I'm calculating here, na? D2.
0, 0, 1, 0.
So this is
No,
what?
sir.
This is 0, 1, 0, 0. Okay. This is MSB.
Okay, yes, okay.
So 0, 1, 0, 0. Okay. This is MSB. Na? I'm making out. This is MSB. D3, D2, D1, D0. So I'm calculating for 0, 1, 0, 0. Like I calculated 1, 0, 0, 0. Opposite. Okay. So now say you want to calculate V. Now this is high voltage. These all are grounded. Again, same thing. You have to solve the circuit. You solve this one. This will come R. Okay. Then R, again 2R. This will come R. Okay. So I will write here now. So this is R. 2R R. So I'm coming up to here. So this is, you have R here. Okay, you have R here, then you have 2R here, and then you have plus E here, and then here again you have a R, and then you have a 2R. Okay, and you want to calculate the voltage here. That is your VA. Okay, so your input to this circuit, this simple circuit input is your 0 1 0 0. Okay. Now you want to solve, you want to calculate what is the voltage here. Okay, so you will learn enough network analysis. Okay, so you can solve this one either using you can solve this one either using so this what is superposition principle, or we learn so many theorems. Which is the theorem?
Thevenin, VThevenin.
VThevenin you can use. Okay, either use VThevenin, you find out the voltage here. Okay, or I'm doing it simply, I'm doing using current division rule. Okay, what I'm doing, I'm using current division. So suppose I current is coming here, some current is going here, some current is going here. If I know this current, I can find out what is the voltage here. Okay, so say now this circuit you can make, you can simplify. So this is a battery, okay, E, and this is resistance 2R, and then further it is dividing like this. You have R, okay, now current is dividing here. So here you have a R and R, 2R. So you have 2R, this is grounded, okay, and further this is R, 2R. So this is your R, 2R. So this I have grounded, this is grounded, this is also grounded. Okay, so and this is your negative, also grounded, battery negative. Okay, so basically now this combination and this combinations are parallel, and this parallel combination RR and RR, this is series of this one. Okay, so what I'm saying, this is your RR basically 2R, okay, and this RR 3R. This branch and this branch connected here and ground. That means this branch and this branch are parallel. So I am putting them parallel. Okay, and this resistance is here series. So here your division. Okay, so your current is coming like this. I current is coming here, and that is dividing in 2R and 3R. Okay, so let us calculate now what is the current I. So current I is simply total voltage upon total resistance. So this is your 2R in series plus these are in parallel. So 2R into 3R upon 5R. Okay. So what become this RR cancel? So this come E upon 10R. So 5E, 10R and 6R. So total 16R. So this is my current equals to 16R. Okay. Now total current is 16R. I want current here. Say I dash. So obviously you can apply current division now. You can solve with many ways you learn so far. Okay, you can use any way. Okay, I'm using this way. Okay, you can use Thevenin theorem. So now you know this I, you want to go to I dash. So whenever you want branch in this current, you have to take the resistance of the opposite branch. Okay, so if I want I dash, that will be total current I into resistance of opposite branch 2R. Okay, and then total resistance 2R, and this is how much? 3R, 5R. This is my I dash. So my now I dash will be I is what? I is 5E, 5E upon 16R. Okay, that is equals to 2R upon 5R. Are you getting this one? How I'm doing? This is I'm applying here current division in this branch and this branch. Okay, so resistance of this branch equal to total plus total resistance 5R. Okay, so now this 5 cancel, RR cancel. Okay, and then you will be left what? How much? 2 power e power 8. So your I is now e power 8, e upon 8. Okay, I dash. So you know the I dash here coming e upon 8. The same current is going here. So you want voltage VA here. That voltage VA will be your E by 8 into 2R. R is also there. E by 8R. So RR cancel, 1 cancel. it comes out E by 4. Are you getting? So first digit it came E by 2, second digit it will come E by 4, or third digit it will come E by 8, fourth digit it will come E by 16. Like I am doing, you can also keep on doing. So this is the basically 4-bit D2A counter. Okay, we have to do it for n bit counter. So this is for second bit. Similarly, for it will come for 3-bit, it will come 2 power 8, 4-bit will come 2 power 16. So I am directly writing now. ये लिख लिया सबने? किशोर, clear है?
Yes, sir. Yeah.
Okay, so you know now like that you can keep on doing. Okay, so that is your homework. So just now I will return for 100 where input is 100. Okay, then I have output VA equals to E by 2. When input is okay 0100, then my output is E by 4. Similarly, if my input is now 0010, my V will be E by 8. Okay, if input is 0001 correspond to LSB, then my V output will be E by upon 16. Okay, this E by 2, E power 2 power 2, E power 2 power 3, E power 2 power 4. Okay, this is a 4-bit counter, so you're getting 2 power 4. Okay, similarly if you have an n bit counter, okay, so for n bit counter, okay, the resolution is equal to weight of LSB, that will be equals to E upon 2 power n. Sorry, this is what? D3. Okay, this will be your resolution of MSB E power 2 power n. And weight of digit, like what is the weight of D3 0100001? So you can write weight of any digit, you can write E power 2 n minus 1. Okay, that will be remain, we'll do later. Okay, this is your resolution to E power 2 power n. Okay, so this is for 4-bit D2A counter. Now suppose we have
we have written that the weight of LSP is E by 2 raised per n. But it is also applicable for the 0010 पे भी applicable हो रहा है.
that is applicable to 001. So particularly इस केस में n क्या है आपका 4 है, 4 बिट. अगर n बिट है तो ये इसका वेट क्या आएगा, जो भी हाई वोल्टेज होगा, अगर सब पे सेम हाई है. ओके, so E upon 2 power n.
Okay, sir.
Okay, so now this is for only 4 bit. I want to generalize it for your n bit. Okay, so for n bit I have VA. so क्या आएगा, पहले आएगा आपका E power 2 power n, फिर आपका आएगा E power 2 power 2, फिर आपका आएगा E power 2 power 3. Okay, for n bit D2 counter, for n bit. Okay, and then it will keep on going. Okay, at last what will come? E power 2 power how much?
2 raised per n.
2 power 2 power n. Okay, very good. This is your formula. Now यहाँ पे मैंने क्या लगाया? This is my dn. Okay, this is my dn. अगर मैं n bit counter है तो मेरा dn minus 1, ये मेरा dn minus 1 है. Okay, ये मेरा क्या हो जाएगा? dn minus 2. Okay, so like this is a 4-bit counter, so this is my dn minus 1. Okay, so this is my dn minus 1. So so instead of E, if I say at MSB I am applying Vn minus 1 voltage. Okay, I'm not generalizing, I'm saying instead of E at MSB I am applying Vn minus 1. So like this is D0 to D3. Okay, so this is a 4-bit, so this is n minus 1, 3. Okay, so I am applying here this one, so I can divide by 2. I can write like this. Okay, Similarly, if I say this is my Vn minus 2 upon 2 power 2, okay, and say this is my Vn minus 3 and 2 power 3, and this is my what last digit d0, this is my d0. So I'm applying voltage v0, I'm applying 2 power n here. Okay, now let us take 2 power n common. So if I take 2 power n common, okay, what I'll get is v0 into 1, that I can write 2 power 0, then v1 equals to 2 power 1 plus v2 2 power 2, and similarly if I keep on going, I'll get up to vn minus 1, okay, vn minus 1 and 2 power n minus 1, 2 power n minus 1.
So this will be taken as full scale voltage ना when D0 D1
अगर ऐसा 1 1 है तो फुल स्केल वोल्टेज जाएगा, अगर ऐसा 1 1 है तो फुल स्केल वोल्टेज जाएगा. अगर इसमें से कोई टर्म को जीरो कर दिया, जरूरी नहीं कि यहाँ पे मैं वी एन माइनस 1 लगाऊं. व्हाट इज द वैल्यू ऑफ v0 v1? वैल्यू क्या है? इट इज 0 और 1. okay
okay sir.
So that is some general formula. So that's how I written this formula. This is your formula for this. This is applicable for general formula. Okay. Now any digit is given, you can find the voltage. Okay. So for example, if I say you have a 4-bit counter, 4-bit D2A R to 2R ladder. Okay. Find the weight of 100. Calculate. And high voltage. Okay. So 100, so 0 is equal to 0 and 1 is equal to 10 volt. कितना आएगा बताओ? फोर बिट है and you want this given. So क्या आएगा आंसर? ये तो 1 मिनट में हो जाना चाहिए. You want the weight of MSB. Weight of MSB क्या होता है? E/2 हमेशा ही. Just now we have calculated.
5
is
sir 5 volt.
5 volt आएगा बस. So what is the digital analog output of this one? So V100. So input is 100. So output will be what? Output will be simply high voltage. Okay, E upon 2. High voltage is 10. So 10 upon 2, that will be 5 volt. Okay. Similarly, if I give you input say 0010, तो कितना आएगा? VA. कितना आएगा? फॉर्मूले में वैल्यू पुट करो. यू हैव Vn minus 1. कितना आएगा? कितना आएगा?
1.25.
10 upon 8. Okay. 10 upon 8 आएगा, 16 आएगा, 8. Okay. 8. So this is 2 4 8, 2 power 4. Okay. So 10 upon 8. So that's 1.25 volts. This answer. Okay. So this is your R to right. So in general, कोई भी इनपुट दे रखा हो आपको, कोई भी इनपुट दे रखा हो तो फॉर्मूले में लगा दो. ओके. एंड if say this R to 2R type of letter, तो वो सिंपल है. हाई इनपुट और लो इनपुट की वैल्यू पता होनी चाहिए आपको फॉर्मूले में. एंड you can find the analog output corresponding to any in a digital input. Now the last topic, the weighted register type D2 counter. The weighted register type D2 counter. Okay, so this is also op-amp based. So you have R, 2R, 4R, and then you have 8R. Okay, so say this is D3, D2, D1, D0. So here I'm giving my input, digital input. Okay, and this is connected to a op amp, minus, plus. Again, this is going like RF is coming here. And this is your grounded. Okay. So basically it is your inverting amplifier. Okay, and now you want to find the V output. Okay, so you know if this is a V output, this is 0, obviously this will be 0. Now here you can apply any digit, higher low voltage, say 1 1 1 1 1 0 0 0 1, anything you can apply, any digit you can apply, and the digit meaning you should know. Okay, then you know inverting amplifier formula. I know what is the formula. Formula will be RF upon R1, okay, minus RF upon R2, and corresponding voltage. Okay, what is the voltage you are applying here? So I'm writing this is D3. Okay, so RF R1 is R. Okay, so if it is N type, if it is N, okay, here particularly this is a 4-bit. Okay, so I'm writing like this. So this, for this one it will be what? RF upon R into D3 minus RF upon 2R into D2, okay, minus RF upon 4R into D1, and minus RF upon 8R into D0. Okay, so basically the formula is minus. Okay, so this is the formula for you for this particular thing. Okay, so if I take minus RF upon R common, this become D3, this become D2 upon 2, this become D1 upon 4, and this become D0 upon 8. So
प्लस में होगा ना?
प्लस में आएगा. So minus RF upon R, that is your D3. Okay, D2 2 power 1, D1 2 power 2, D0 2 power 3. So this, so if it is an n term, you can keep on going like this. This is a 4-bit, so it's coming up to 3. If it's a 5-bit, it will come to 4. Okay, if it's an n bit, it will come up to n minus 1. So for n bit, okay, n bit, what I can write, V0 will be minus RF upon R. Okay, this is the weightage, R2 or 4. Okay, this will come RF on R upon D3 Dn. So this is Dn minus 1. If it's a 4, so it's coming 3, so it come n minus 1 plus Dn minus 2. Okay, let's keep on coming. D1 2 n minus 2 plus D0 2 power n minus 1 is the formula.
सर Dn-2 पे भी डिवाइड होगा ना?
2 power
सेकंड टर्म में
n minus 1. जैसे यहाँ पर 4 बिट था ना, तो 3 आया था ना.
यस सर.
तो यहाँ पे सेकंड वाली में, तो यहाँ पे तो जैसे 4 बिट तक तो 2 आया, तो 4 minus 2 आया था, यहाँ n minus 2 आएगा.
यस सर, इससे भी पहले वाले
इससे ये वाला बोल रहा हूँ. अच्छा,
यस सर, यस.
ये वाला इसमें आएगा.
सर सर ऐसे जब हमने ये सर्किट बनाया तो फिर जनरलाइजेशन में मतलब कि ऐसे R2R 4R 8R फिर 16R.
हाँ, ऐसा 16R सर्किट ऐसे कंटिन्यूअसली मल्टीप्लाई होता जाएगा.
ओके सर.
उसी क्वेश्चन के लिए करना है. ओके, नाउ फॉर एग्जांपल you have this 4-bit, okay, 4-bit counter. You have a 4-bit counter, okay, this type, weighted register type. Okay, and you have been given 0 equals to 0 volt and 1 equals to 5 volt. Okay, So they're asking if RF is equals to R1 is equals to 1 kilo ohm, okay, then what is the weight corresponding to 1111? Find what is the weight corresponding to 111? Basically, this formula, this factor become 1 automatically. RF equal to R is same, okay. So this factor almost is become 1, okay. So this become minus. Now Dn minus 1, this 4 bit, so D3 is also 5 volt, D3 D2 5 by 2, D1 5 by 4, and then last D0 again 5, D power 8. So tell me how much is coming. How much is coming? 9 point something coming.
So minus 9.375.
Yes, minus 9.375. This is your answer. Okay. So I'm stopping here. Okay. So we have completed our digital circuits. Any question, please ask. So there's time for other class. I have to stop.